Hi everybody, this is Gigi from Kauai Community College. In this video, I'm going to show you the difference between the two um, definition of derivative that you see in your book versus what you see in my lesson video. I feel like I need to clear this up, so here it is. Okay, now in your book you might see a problem like this, right? Find the slope of the tangent line, or like find the velocity at a certain moment, which means you have to take the derivative and then plug in the right? So at 1, the derivative at 1. So really this question is asking, what is the derivative evaluated at 1? Okay, so that's what this question is asking. Okay, now you could use the definition that was given in your book or in MyMathLab, which is the derivative at some point A is limit as x goes to a of f of x minus f of a, all divided by x minus a. Okay, so now what is this? This is the derivative at a given point A. Okay, so in this problem, we are looking at the derivative at x equal to 1. So we are really looking for what is f prime of 1. And that is limit as x goes to 1 of f of x, which would be 4x squared minus 5x, okay, minus f of 1. Okay, so what is f of 1? When you plug in 1, you are going to have negative 1, right? So this right here, f of 1 is 4 times 1 squared minus 5 times 1, which is negative 1. Okay, so that is minus negative 1 all over x minus 1. Okay, now what you are to do at this point is to get rid of the x minus 1 by factoring, just like how you would try to get rid of the h in the other definition which you have been working with if you were watching my videos, right? So x goes to 1 of, and minus is a plus, and then I get to factor this thing here. And when I do, it would be 4x minus 1 and x minus 1. And then on the denominator, I have x minus 1. And as you can see, x minus 1 divided by x minus 1 is 1, right? So dividing is 1, right? I stress the idea of division rather than saying, oh, it canceled, that factor canceled out, because really we are dividing to undo that multiplication right there. Okay, and canceling seems like it was just going to disappear. It's gone. It's not. It's 1. And then 1 times x minus 1 is 4x minus 1 is still 4x minus 1, right? Now, the question now is saying, then, what would the limit as x go to 1 of this expression here turn out to be? I'm not sure why I have an issue talking today. So when x is 1, when x is approaching 1, this is going to be close to 1. So we can do a direct substitution here. So that would be 4 times 1 minus 1, which is 3. So we would say then that the derivative evaluated at 1, or the slope of the tangent line at x equal to 1 is 3. Okay, when we substitute the 1 into there. So with this definition, you are able to find the slope of the tangent line, or the derivative at a given point. Okay, so you're looking at a given point. Now, the definition that I have been talking about is this. It's the derivative function is limit as h goes to 0 of f of x plus h minus f of x all divided by h. What's the difference? The difference is this, right? That said, the derivative at any given point x, whereas this definition is saying the derivative at a. Okay, so that's different. This right here, when you do the derivative and you do the calculation, you actually get a value because that's what it is. You're looking for the derivative at point A. Whereas here, you are looking for the derivative function. So you'll end up with some kind of function, right? So the same problem, but I'm going to approach it this way. So then the derivative function is limit as h go to 0 of f of x plus h, which would be 4 times x plus h squared minus 5 times x plus h, all that minus f of x, which is 4x squared minus 5x. Okay, then we are going to go ahead and expand limit as h go to 0 of, and I also noticed that some of you write equal right here. There's no equal there. The equal sign is over here. It will say then the derivative function is the limit as h go to 0 of this expression here. Okay, so h, and then here multiply this out. I have 4x squared plus 8xh plus 4h squared minus 5x minus 5h minus 4x squared plus 5x. And then here is when magic happens, right? 4x squared minus 4x squared is 0. 5x, negative 5x, right? 5x minus 5x is 0. And then everything else has an h in it. And then I am dividing by h. So I will have the derivative function in terms of x is going to be, take the limit as h go to 0, right? Oh, actually, I'm going to go ahead and write that down first before I take the limit. I would say that would be the limit as h goes to 0 of, what is this here when I divide everything by h? I have 8x plus 4h minus 5. And then when h is approaching 0, I will have this right here is going to be very close to 0. So then the limit is going to equal to 8x minus 5. Okay, so we are saying the derivative function is ax minus 5. Therefore, if you were looking for the derivative at 1, evaluated at 1, then you can just put 1 into here where x is. And so I will have 8 minus 5, which is 3. Same answer, right? So you would say, well, why then are we going down this road and use this definition rather than the other one where we can just go ahead and find a derivative at a point? Well, usually, really, in real life, we are interested in, and we always ask, well, what if, right? So what if I want a derivative at 2 instead of at 1? Well, if we were using this definition here, I'm going to have to redo all of that process for a being 2. And I have to go and do all that factoring, dividing things out, take the limit, and then find that particular slope. Now here, because I have the slope function, if I want the slope at x equal to 2, I can just now go ahead and plug in 2 for x. So then I would have 2 times 8 is 16 minus 5 is 11, right? So I think I like this better just because then I am looking for a slope function, and I can just go ahead and have that function to be evaluated at any point I want to and not have to repeat the process in case I want the slope at different point, right? So that's the difference between the two. This definition here is the slope at A, and here is the slope function. That means at any given point x rather than just at a particular point. And that's the difference between the two definitions.